This meeting is being recorded.
Cool. Um, yeah. So we were talking about the so we were talking about so command parser. So command parser, it checks if there is any syntactical errors, right? So syntactical errors is this. So if there is any syntax errors, so it gives that error and it so send it back to the client with the TDS packets, right? So I will so I'll explain. So it will send the same result set, right? So it gives an error and it will send the same, so it sends that error, I mean the information to the client, right? So if there is any syntactical errors, that is what command parser does. If there is no syntactical errors, then it will go for algebraizer. So algebraizer is nothing but your schema binding, right? So schema binding is nothing but, so this person, so for example, let's say if I execute this person and these two are different select queries. If you are not so understanding, so these two are two different because it is bind with a different schema, right? So if you use select star from person.person, so it can be a different so table, it can be a different table, right? For example, let's say I'm going to drop the table because it is being used for replication. Okay, I'm sorry. Yeah, that is fine. So you can drop individual tables, right? For example, create table person one, right? So if you execute okay, let me put this into read write. Cool. So let it be. So I can create the table with the same name. So I have created, and this table and the table, like so it is created with this, right? So this is uh, what we call this as a DBO. It is a default schema, right? So this is the DBO schema. It will be created with. So this is called schema binding, right? So it will bind the schema and execute this query. So this is a different ID. And if you execute person, so it has multiple columns, right? So this is the schema binding. So once the syntactical errors is verified by the command parser, then it will be going to query algebraizer. So where it will identify that schema binding and it will go forward to the query tree, right? So query tree, right? So query tree is basically, so this, the query will be divided into multiple parts or multiple segments. Consider as a normalization. Uh, so if you're not, you have any questions?
To configure Mirror, we are going to use 5022 as an endpoint. 5022, 5022.
Sorry, right? So once command parser verified that syntactical errors, or then it will go to the query command, that then it will go to the algebraizer, so where it will identify the schema and it will bind the schema with the tables we have, right? Then once it is bind, then it will go and so create a query tree, right? So query tree, it will be generated by the command parser. So query tree is basically, so dividing the query into smaller granular, so sections, or dividing the query into multiple parts or segments for the better optimization. right? I'll have a I have a diagram, like, so I'll show you that how that looks like, and I'll explain this. So for now, understand. So the query will be divided into multiple parts or multiple segments. You can consider it as a tree nodes, and for a better optimization and performance. Then, so it is generated a query tree, right? Once this query tree is generated, then it will verify, the command parser itself verify if the plan is exist at the plan cache. So whether it checks whether plan is available at the plan cache or not. So plan cache is where we store the plans in the memory, right? So I'll explain in detail, so when we talk about the plan cache, but memory, plan cache and all, but for now, understand that plan is a pre-compiled or pre-compiled. For example, let's consider a building construction, right? So if you're going for construction, or if you're builder going for a building construction, so it's a kind of apartment with 10 houses, right? So if that is the case, he'll create a plan to construct a house or construct a building, right? So that plan, he will create a plan for one flat. For example, let's say you have apartment and 10 flats to be constructed, and he will create a plan for one apartment, and that plan will be saved so that no resources can be utilized to create a plan for next flat or apartment, right? Next flat, basically, within the same apartment, so that he no need to create a new plan, right? He will not waste his time and resources and all. He will be saving that plan so that he can use that plan for the next constructing a flat or next designing a flat. So the same way, so if we execute a SQL query, so we'll have to have a plan to execute that particular query. So that plan will be so saved in the plan cache, right? So I will tell you who will generate the plan and how that will be executed. But for now, understand that we have a plan cache where the command parser will check if the plan is already exist or not. If the plan is not exist, then it will proceed that query tree. It will proceed that query tree to the query optimizer, right? So this is the query tree section. So it will be sent to the query optimizer. What if the plan is already exist? So if the plan is exist, then it is simple. It will go to the query executor, and query executor will execute the query, right? We'll come to that point. Let's consider in our scenario, we don't have a plan. So if you don't have a plan, then it will be going to the query optimizer. So what is query optimizer? What query optimizer does, right? So query optimizer, so basically it checks if query optimizer is a cost-based optimization. So what is cost-based optimization? So it checks various you can consider various points to consider a plan generation, right? So various points to consider a plan generation. So before generating a plan, it will check what are all required to generate a plan. So what that we will go through and we'll understand more in detail, right? So query optimizer, what exactly it does? So query optimizer, as I said, like cost-based optimization. What do you mean by cost-based optimization? So whenever you need a query to be executed, so that needs some cost, right? Some cost to be calculated. So the cost will be calculated based on some resources. For example, let's say how much CPU it requires, how much memory it requires, how much IO it requires. So it will calculate and estimate all these components, and then it will generate a plan, right? As I said, like it is a cost-based optimization. For example, so this is your so this is your optimizer. So this is your optimizer. Whenever you execute select star from table, so within the fraction of seconds, it calculates and estimates, so thousands of plans, right? So I would say, like, so I don't have exact value and we cannot estimate exact value, but it verify thousands of plans to so understand which plan is better for this query to execute, right? So which plan is better to understand, it will understand which plan is better so that your query will be executed based on that. So what and all it will validate? So it will check how much CPU, it will understand memory utilization, how much IO is required. So these are all the resource utilization for this query. So it will identify this and it will generate a plan, right? IO. And the important thing, like statistics, so I will so explain statistics in a detailed section, but for now understand statistics is a data distribution. For example, I have 1,000 rows in my table. So how this data is distributed, right? How this data is distributed. So I'll just give you a high level. 1,000 rows in my table. So in this 1,000 rows, how many rows are duplicate? How many rows are unique? How many rows so or with the name ABC? Or how many rows so you have that value, how many rows we have, starting with between 1 to 100, right? Value 1 to 100. So this is called data distribution. For example, duplicates are 10 and uniques are 2. So likewise you have, and you will understand that the data distribution with the help of statistics. And optimizer will completely depends on the statistics to identify the data distribution, right? So we will talk more in detail of the statistics when we talk about the query performance and all, right? So this is a high level overview. It will identify the data distribution in a table, right? So if you have a table, so how the data is distributed. So statistics and all, it will identify and generate a plan based on that. So this we call it as a so there are different levels of optimization. First is zero optimization. So what is zero optimization or non-optimization? If your select query is simple, right? So this is a select query, simple select query, select star from table. So we don't have any joins, or we don't have any anything we don't have. So it is a simple select statement. It is called zero optimization. We no need to optimize, and we cannot optimize this, right? It is just a select query. Or even though if you execute with some specified column 1, column 2, so whatever it is, so it is just a simple select statement with zero optimization. It is a zero based query. We call it as a trivial plan, right? So trivial optimization, trivial query or trivial plan, and this will be generated a execution. So that I will talk, but yeah, so this is a zero based optimization. And second thing, if it is not trivial query or trivial plan, then it will check what is the index usage. We will talk more in detail about the indexes as well. For now, understand that it will check if there is any indexes used for this query, right? So any indexes which are required. Then so third stage, like it will check if there is any similar query we have in the plan, similar query or similar plan exists. So similar query is nothing but, for example, let's say you have select star from table. So if you have select name, first name, last name, and from table, so it's a kind of similar, right? So it will check if the similar plan exists. If the similar plan exists, it can take that plan and you can proceed with that execution plan. So it will check that whether the plan is exist or not. So this will be taken care by the optimizer. Fourth one, the statistics and parallelism. So the optimizer, it will check whether the query is going for parallelism or not, right? So parallelism, in a simple words, it is executing by multiple threads. So we will talk about the threads, so when we talk about SQL OS in detail, right? Parallelism is nothing but you, instead of executing on one CPU, we are executing on multiple, right? So we will talk about that. So it will check all these points before we generate a plan, right? So this is a simple select statement. It is a trivial plan. It will be generated. We don't have any optimization. It is just a simple zero based optimization, and optimizer will generate a plan for this query, right? So this is a high level overview how it looks like. For example, this is a compilation steps, right? How the compilation happens whenever you execute a query, how it go for compilations, right? First, so as you know, it is going for parsing. So it checks any syntactical errors. Then it creates a tree, and right? So sequence tree or query tree. Then it will go for normalization. So what is the normalization? Is nothing but divide, or so divide the query into multiple segments or multiple parts, so that it is not a complex statement to execute, right? If it is a big query, so it is difficult, or it takes more time to generate a plan, right? Instead of that, what it happens, or what it does, it divide the query into different segments, right? Different segments to normalize the tree, right? So you must have read like normalization, right? I'm not going into that normalization, first normalization, second normalization and all. So where the table will be divided into multiple, so multiple parts, the same way the plan or the query will be divided into multiple parts for the better optimization. And it checks whether it is a DML statement, right? So DML, so any modifications, insert, update, delete, or anything. If no, then the query will be compiled, and the T-SQL statement, compile the T-SQL statements. So if it is not DML statement, so if it is a DML statements, so we will talk more, we will talk about update query, how that works. Let's say, for example, if it is a DML statement, then it will be created, this will be converted into a query graph. So query graph is basically, so kind of a query plan, but it has some more information in that plan, right? So for example, let's say we have something called write ahead logging, and we have something called logging, log manager, and also it will identify that whether if there is any DML operations that we have, right? And so optimization, I will show you that next slide, but optimize the query graph and then produce a query execution plan. So it generates a query execution plan, right? So this is how the compilation happens, right? It will check what is the statement, and based on that, compilation go for. This is the optimization. So what is the difference here and here? Once it generates a plan, then the plan should be optimized to execute it faster. So optimization is nothing but execute the query in a faster way, right? That's it. So we have the trivial plan optimizer. So let's say, for example, this is a trivial plan. If we find the trivial plan, then nothing. So we just, so compile that and we will execute that query, right? So let's say it is a trivial plan. Yes. So if it is a trivial plan, then we execute this query, right? So we don't so consider much. If it is not a trivial plan, then it will go for simplification. So what is simplification? Is divide the plan into multiple segments to proceed further, right? For example, you have 4 tables joined together, right? So you have 4 tables joined together. So you have to calculate each and every table to understand how that works. For example, let's say 4 tables, table 1, table 2, table 2, 3, 4, right? So this structure like statistics will be separate for each table, right? So this will be identify the statistics, and it will load the data. I mean, statistics will be identified based on the simplification of the query. Then this cost based phase 1 to n number of times. So I told you, right? So the phases are these. So these we call it as a phases. So it will check if there is if it is a zero optimization, or it checks if there is any indexes which we are using, or if it will check if there is any similar query we have in the plan cache, or any statistics, or it go for parallelism and all. It will check. That is what we call it as a phases, right? So it will check each and every phase, and if found a cheap plan, so it will identify the plan based on this optimization. It will find a plan, right? So one thing to remember, query optimizer will not take the will not get the best plan to execute. It is just an optimal plan for your query to run faster, right? So best plan is different and optimal plan is different. So best is nothing but, so it will keep on, so retrieving the plans to get the best plan. But query optimizer is not that. So if it identifies this cost is enough for SQL to query execute, then it will pick that plan and it will go for execution, right? That is what optimizer does. Cheapest cost is greater than parallelism threshold. So it checks if the cheap plan is found. Yes, it found, then the query will be executed. What if the cheap plan is greater than parallelism threshold, right? So I don't know how many of you heard cost threshold for parallelism parameter, right? Cost threshold for parallelism, it will decide whether my query go for parallelism or not. That is what it tells. If that cost of this query is greater than that, then it will go for parallel execution. If not, it is a serial execution, right? So we will talk more about the parallelism and cost threshold for parallelism in detail. For now, understand this is the optimization level of it is the steps to optimize your query, right? So any questions? So any questions?
Yeah, Shanmugh, what do you mean by the trivial plans?
Chandu. Trivial plan, I told you, right? So if it is a simple select statement, we call it as a trivial execution, trivial plan. So we don't have any optimization levels. It is just a simple select query. For example, this is simple select statement, select query. We don't have any, so joins or something. It is what we call it as a simple trivial plan. For example, so this is plan. So this is simple trivial plan. We don't have any optimization, we don't have any indexes, we don't have any so anything which is not indexes, joins, so triggers, nothing. So it is just a simple select statement, so we call it as a trivial plan, zero based optimization plan, right?
Okay.
Good. So any more questions? So is it clear, like, so this might not be used in day to day, but if you explain this or if you understand this, then it is better for you to troubleshoot. For example, let's say your query is running slow, right? So you just correlate this architecture with your day to day, so life or work, right? So your query is executing slow. So if your query is executing slow, let's say, so if your query is executing slow, so based on this information, what we need to check, so statistics. So first thing, statistics are so actually loaded properly or not. So what do you mean by load? So is basically updating or not, right? So we'll have to check the statistics are up to date or not. So then we'll have to check the cost. What is the cost of this execution? Whether this is more than cost threshold for parallelism or not, right? So you will have to identify these two. So then based on that, you will have to go forward, right? So first thing, you'll have to check statistics are up to date or not. Second thing is you'll have to check the parallelism. What is the query it is going for, right? What is the cost of the query, right? So based on the cost, you will go forward. Cost is nothing but, for example, if you see here, this is the cost, right? So cost is 0. I mean, so cost, this is the overall estimated operator cost. This is the total cost. Right, so we don't have any data, so that is the reason it is showing that as whatever 00. But if you execute this, the cost is changed, the subtree cost is so it is giving something, right? Subtree, this cost, whatever subtree cost is combination of this upper downstream plans, right? So this is what we call it as a cost. Cost cannot, is not measured in like for example minutes or percentage, whatever it is, it's just a cost of the operator, that's it. So we see that as a cost. 5, 10, 20, like that, we have a cost of this operator, right? So this is how that we correlate, right? So this is how it will generate a plan. So based on the cost, so it generates a plan based on the so statistics, or based on based on the optimization level, right? It generates a plan. Who generates a plan? Optimizer will generate a plan of that query, right? So optimizer generates a plan, and the plan will be stored in the plan cache, right? So once the plan is generated, that plan will be stored in the plan cache for a later usage. And then optimizer will send that execution plan or query plan to the query optimizer, query executor. So query executor is where exactly so execute the query and get the data for us, right? For the client. So query optimizer send the query so query plan to the query executor, and query executor will start executing the query. Just a high level, I will just so tell you that until this point. First, for example, let's say you have a select query, and from the client you execute the select query, and it will be sent to the SQL Server Network library using TDS packets. TDS packets are so wrapped so your text or SQL query will be wrapped into the TDS package, and it will be sent to the network library of the SQL Server side. And once it is received by the SQL Network Library interface library, then it will unwrap this TDS packets, and it will send that text or language event to the command parser. Command parser, it will check if there is any syntactical errors. If there is any syntactical errors, it will be sent back to the client with the TDS packet. And if there is no syntactical errors, then it will be going for a so then it will be an algebraizer where it checks the schema binding, right? So when if there is no if it is binded, the schema binding is done, then it will check if the plan is already exist in the plan cache or not. So if the plan is not exist in the plan cache, it generates a plan tree, query tree, right? So it generates a query tree. Query tree is nothing but you have a huge query, and it will be divided or normalized into multiple parts, and it will be sent to the optimizer. That query tree will be sent to the optimizer. So optimizer is a cost-based optimization. It will identify the cost, and it will so take some measurements and some parameters. For example, let's say statistics or CPU. So it will identify how much cost is required for this query. It will keep on retrieving multiple plans to get the optimal plan for executing your query, right? So it generates a plan, query plan, based on the resource usage or utilization and your query as well. Then it will send to the query executor. So query executor, it does actual work to get the data, right? So query executor, it will so communicate to the storage engine. For example, let's say you have a select query where it needs some pages. For example, one sec. So don't worry about it. So just I will explain this as well. So you're executing this query. So you need 19972 rows, right? So if you see that messages, you need logical reads or 3830. So what does it mean? You need these many pages to get the data, right? So you need these many pages. So basically you need these many so pages, whatever it is, 3800 pages you read, you need to get the result, right? So then we will be where that pages will be stored and how that will be retrieved. So here this part, the storage engine. Query executor will communicate to the storage engine to get the result set, right? So how this will be communicated, we have something called OLEDB provider. So here OLEDB. So OLEDB communicator or OLEDB connection, right? So executes and connects to the access method. I mean storage engine through the access method. Access method basically it will not do anything, but it has a code structure. It has some logic to get the data, right? So to get the data is nothing but, for example, let's say this query needs 3000 pages. So how SQL Server understand this needs 3000 pages? This access method will understand how many pages we need to get the result set, right? So it identifies that it needs 3000 pages. Then immediately it will send that information to the buffer manager. So what this buffer manager does, it checks whether the pages are available in the pages are available in the data cache or not. So data cache where we store the pages to read the data. So so if you execute this query, so if the pages are not available or pages are there in the disk, so we will not execute this query. We will not get the data. So when you will get the data, once these pages are available in the memory, then only we get the result set, right? These pages should be available in the memory to get the data, right? So that place is this one, data cache, where we store the data pages. So it will check whether the pages are available in the memory data cache or not. If the pages are not available, then this buffer manager will communicate to the data file. This buffer manager will connect to the data file and get the pages which are required, right? So this buffer manager will so get the pages from the data file and it will place it in the data cache. These pages, whatever pages we require. Once the pages are available here in the data cache, then the results will be retrieved, right? For example, let's say you have 19,000 records. Those records will be retrieved and it will be sent to the access method. From access method, it will send it back to the query executor. So query executor will send that result set to the network layer, and network layer will be zip that, like, so it will be encapsulated or it will be wrapped that into a TDS package and it will send it back to the client. And client side network library, it will unwrap this packet, TDS packet, and it will, so read the data. So this is how that works, right? So this is called buffer pool, where we store the pages or data pages, and where we have planned cache, it is in the memory itself. And this transaction manager, I will explain most probably so tomorrow, because this we will have so update query. So I will explain this tomorrow. For now, so transaction manager, so update query or insert any DML operation, so this will come into the picture, and the log, transaction log also will come into the picture if there is any DML query, right? For select query, we will not write anything into the transaction log file. It is just a select statement where we read the data and get the result set to the client, right? So where we have buffer manager, where we have dirty pages, so you must know, right, what is dirty pages, and also I will not explain, but so in a high level overview, if you modify anything which is there in the data, which is there in the buffer pool, we call it as a dirty page, right? For example, you read the page from buffer pool to the disk. So whatever pages you read from buffer pool to disk, disk to buffer pool. And once it is read, and if you do any updates, right? So we will talk update query tomorrow, but if there is any update, then that update will be modified this page or data in this page. We call it as a buffer. We call it as a dirty buffer or dirty page, right? So yeah, so this is completely into a storage engine where we have, this is a relational engine and this is protocol. So any questions? So we will talk more like, so storage engine. So we will talk about log manager, and, so write ahead logging, how that works, write ahead logging, so how the transactions acquire a log. So we will discuss a high level of latching as well. So latch also, so we will discuss, I'll discuss tomorrow, so that you will understand how that works whenever you read, whenever you, so perform any modifications, right? So even latching or locking, even in a select query, we need that locking and latching, but that is just for sake of simplicity. So I have not mentioned here, or I have not, so explained here. So we will talk tomorrow in detail, right? So